Students, this is lesson U1A07d. Hopefully by the end of the period, should be able to say I can solve intersections between two lines, algebraically or graphically. So in this lesson, it's actually a lot of review. So what I'm going to do is I'm going to go through this worksheet and just remind you of what were some of the skills that are needed to solve a system of equation, either graphically or algebraically. So in this case here, let's take a look at question 1. We need to solve each system by graphing. All right, so let's do that. Looking at the two equations that are provided for us right now, these are in slope-intercept form. So therefore, I'm going to graph the first equation there. I'm going to pinpoint y, 1, and then I'm going to go up 3 and over 4. And I'm going to go in the reverse direction the same way. So this is the line that I end up with. All right, and then we have -4 and with a slope of -half. So -4 is here, and slope of -half is going to go in this direction. So it looks like that right there is going to be our point of intersection, which is -4, -2. All right, let's take a look at the next one. All right, x equals to -4. Remember, that is the graph of a line that is vertical. So -4 will be right here. Next is y is equal to x plus 3. So I have 3 here. And it has a slope of 1. So up 1 over 1, and same in the reverse direction. So it's going to go like this. And the point of intersection will happen right there, which is again -4, -1. Let's take a look at the next one. I have a y-intercept of +4 and a slope of -2, so it's going to go down 2 and over 1, down 2 over 1, down 2 over 1, and so forth. And then I have a line that is y is equal to x plus 1, starting at 1, and then we'll go up 1 over 1, up 1 over 1, and I already see the point of intersection. The point of intersection is right here, which is at 1, 2. All right, moving on. Question number 4. I start at 3, and I have a slope of 1/4, which means I'm going to go up 1 and over 4. And I'm going to go in the same manner in the reverse direction. So it's going to look something like this. And then I have a slope of -4. I'm sorry, a y-intercept of -4 and a slope of +2, which means I'm going to go up 2 and over 1, up 2 and over 1, up 2 and over 1, and so forth. So I'm going to have something that looks like this. So this is going to be our point of intersection. The point of intersection is 4, 4. So that's 4, 4. All right, here are some of the questions that needs to be solved algebraically. So looking at this, I have 2y is equal to -3x plus 8, and -12 minus 3x is equal to 12y. So I will need a little bit of space. So I'm going to write on the side over here. So I will bring over all the variables over to one side. So I have 3x plus 2y is equal to 8. And I'm going to subtract over the 12y and bring over the I'm going to subtract over the 12y and then add both sides by 12 so that I have everything set up in this manner. Now, why am I doing this? This is perfect setup for solving a system of equation by elimination. So how are the variables going to be eliminated, you may ask and wonder? So again, just like the skills that we have applied in over the proofs, skills that you had applied when solving a system of equation back in when you guys were studying algebra, we add equations just like we would add numbers. So if we add the two equations here, we will end up with -10y is equal to 20. Divide over by -10, we end up with y is equal to -2. If y is equal to -2, We then substitute that back in. And we can see that we end up with 3x minus 4 is equal to 8. Add 4 to both sides, we end up with 3x is equal to 12. Divide by 3, we get x is equal to 4. All right. So question 6, very similar, but in this case here, rather than solving it by elimination, I will solve it by substitution. I want to isolate x. X, as it turns out, is -3. And we then substitute that into the second equation. So we end up with -12 plus 9 plus 3y is equal to 0. -12 plus 9, that's -3. So we end up with 3y is equal to +3, or y is simply equal to 1. Okay, moving on. Question number 7, I'm going to solve it a little differently. Instead of solving it by elimination again, I'm going to solve it by substitution, just to vary up the different techniques and remind you of the different techniques that exists. So here, what I'm going to do is I'm going to take that and I'm going to isolate x. So if I isolate x, I end up with 2x is equal to 2y minus 6. I want to divide both sides by 2. We end up with x is equal to y minus 3. So this is what x equals to. I'm going to now substitute that into the second equation. So if I do that, I end up with -6, or actually 0 is equal to -6 minus 3y minus 12 times y minus 3. I'm going to perform the simplification. We end up with -6 minus 3y minus 12y plus 36. Bring everything over that doesn't have a y and combine everything else on the other side that does have a y in it. So I'll end up with -30 is equal to -15y, or y is equal to 2. Now that I have y is equal to 2, I substitute that back into the equation for x. So 2 minus 3, that's just -1. Question number 8. This looks like it's set up. I'm going to try to set this up using elimination. So maybe you're wondering, you're asking yourself, like, well, how do I know which method to approach, whether to use elimination method versus substitution method? It really just depends on how the person feels. So you can solve this in any which way, and based on experience, based on what you're comfortable with, okay, whichever way that you find to be simpler, okay, is always going to be the best approach. So, but for coming from my experience, if I notice that there's absolutely no common factor here, then more likely than not, it would be more appropriate to solve this type of problem using elimination method. So if I have 3x, I'm going to bring over to 9y, so I have 3x minus 9y is equal to 18. And the idea is I need to eliminate this. Now looking at the both equations here, I notice that the y's have opposite signs, coefficients that have opposite signs. I want to take advantage of that because the moment I add the two equations, I want things to eliminate. So, and the only way that they do eliminate is if the signs are opposite one another. So I'm going to multiply the top equation by 3. So I end up with 6x plus 9y is equal to 9. And the bottom equation I leave alone because if you notice I have the same coefficient but opposite signs now for y. If I add the two, I end up with 9x is equal to 27. Divide by 9, I end up with x is equal to 3. So if x is equal to 3, I then substitute this back into either equation, either the first or the second. And it looks like maybe the first equation is simpler, so I'm going to put that back in. So it's 2 times 3 plus 3y is equal to 3. Subtract over, I'm So I end up with 6 plus 3y is equal to 3. Subtract both sides by 6. 3y is equal to negative 3. Divide by 3. Y is equal to negative 1. See you on the next video.